A solution containing a 3+ ion is electrolyzed by a current of 5.0 amps for 10 minutes. So now we're giving you the amperage and we're giving you the time. Okay. The question is, what is the identity of the metal? What is the identity of the metal if 1.18 grams of metal is plated out during this time interval? Okay, so let me just draw a pictorial of this and see what's happening. I'm only going to draw one compartment. We have this thing here. We have an external power source. I'll just call it PS. And we have some metal ion that happens to be 3 charge. I'm going to run 5 amps of current through this thing, push 5 amps, okay, 5 coulombs of charge for every second into here, and I'm going to do that for 10 minutes. As I do that, the metal ion is going to be reduced. So it's going to start plating out. It's going to start actually depositing right on the metal itself. Well, let's say I already weighed out this metal electrode before anything plated out. And then after the process was done, after the 10 minutes, I take it out, I dry it, and I weigh it again. The difference in the weight is 1.18 grams. That's what it's saying. This deposit is 1.18 grams of the metal is actually plated out during this time interval. We want to know what that metal is. Well, the only thing we know about it is that it's a 3+ ion. Okay, well, first of all, let's just write the equation so we understand the number of moles of electrons that are transferred. So metal goes to metal 3+ ion plus 3 electrons. I could have written it the other way. It doesn't really matter. I could have written M3+ plus 3 electrons goes to M. It really doesn't matter. Now, when they say identity of something, and when they give you the grams, here's what you need to identify something: molar mass. You need to know its molar mass. This is a metal. This is an element, something. You need to know its grams per mole. So we need to know grams per mole. Well, we have the grams already. That's 1.18. What we need to know is how many moles of this metal are actually deposited. 1.18. So this is what we need. Okay, let's see what we can do. If you want to go back and refer to that pictorial, let's see, what do they give us? They give us 10 minutes, and they give us 5 amps. So, time. We have 10 minutes times 60 seconds per minute. And the reason is because amperage is coulombs per second. That's the second is the time unit for the amp. Times 5 coulombs per second plus 96,485 coulombs per mole of electrons times 1 mole of metal. 1 mole of metal comes from the transfer of 3 moles of electrons. That's it. Min, S, C, mole of electron, mole of electron. I'm left with moles of metal, and my final answer is going to be 0.0104 moles of metal. Now, let's go ahead and go here. So we have 1.18 grams which consists of 0.0104 moles, and I end up with something like 113.8 grams per mole. When I look at a periodic table, I'm going to be somewhere in the cadmium or indium range. Well, cadmium doesn't have a 3+ ion. As it turns out, indium does have a 3+ ion. It just happens to be underneath the aluminum column. So in this particular case, our answer is going to be indium. Now, granted, this is a real-world process. It's not going to be exactly what the molar mass is. You're not going to get like 111 or 112 point something. It's going to be in that range. This is the thing. There are tolerances in science. Yes, science is exact, or we try to make it as exact as possible. But in things like this, again, it's not going to be, if you end up with 113.8 and you have maybe 3 or 4 different things and you're like, well, wait a minute, which one is it? Is it cadmium or indium? Or maybe it's the one before cadmium, maybe it's the one after indium. Well, you have other information at your disposal. And the other information is that cadmium doesn't form a 3+ ion. Indium does form a 3+ ion. The thing right after indium doesn't form a 3+ ion. So indium is our guess. Okay, so that's it as far as electrochemistry is concerned. We've discussed galvanic cells. We've discussed cell potential, work. We have made the connection between cell potential and thermodynamics, cell potential and the equilibrium constant. And we've finally discussed electrolysis. So hopefully everything everything that's important has been discussed. With that, I will see you next time, and we'll begin our discussion of light and quantum mechanics. We're actually going to be going back to talk about some things, what I consider to be in the middle part of chemistry, the quantum mechanics, the bonding, the solutions, some of the things that I actually skipped because I wanted to spend a fair amount of time on the kinetics, the equilibrium, the electrochemistry, and things like that. So until then, take care. Thank you for joining us here at Educator.com. Bye-bye.